Good day everyone, this is our group discussion in Structural Theory CE4 Section 3 presented by Christian Mancognahan for analysis of indeterminate frame using Portal method, Daniel Diwara for analysis of indeterminate frame using Cantilever method, John Lloyd Gilo for moment distribution method, and three-moment equation for Emmanuel Eric Cinco. Thank you.
So, good morning. I am Daniel C. Diwara. I'm going to discuss about the analysis of determinate frames using cantilever method. So, we have two assumptions in the analysis of determinate frames using cantilever method. The first one is the point of contraflexure occurs at the middle points of the various members. So, sabat daw, our frame composes of two members, which are the vertical one siya, column, and the horizontal are the beam. So as you can see, there are four columns, and let's say na they have the same cross sectional area. So pasabot, let's say same naman sila cross sectional area, then let's assume that this is the A, and A. So we have 4A. And then according to Verringon's theorem, since we have already 4A, x bar is equals to the also, before I forgot, we have to the first step is that we have to locate the centroidal axis. So let's assume that in our frame, this will be our centroidal axis here, and this column will be our reference column. And let's say that from our reference column to our centroidal axis, let's denote this into, this one will be the x bar, and then also this column here to our centroidal axis will be denoted as x2, and then the third column to our centroidal axis will be denoted as x3, and then our last column to our centroidal axis will be denoted as the x4. So in order to get all of this, we need to get our x bar. So we're going to solve for x bar. So according to Verringon's theorem, since we have 4A x bar, then the area 1, since this is our reference column, it doesn't have a distance. So from our second area or the column is that our first this is our reference column, and then the distance gikan sa atong reference column to our second column will be 5. So times 5 plus kanina pong third column na to gikan sa atong reference column will be 10. And then same na po dere sa atong last column, which is 15, yung distance gikan sa reference column. Then solve lang na, plus lang, 5 plus 10, 15 plus 15, which is 30A. So copy lang na siya dire, x bar. Then let's divide both sides by 4A para makuha na to atong x bar. So x bar, input lang na to sa atong calculator. We will have a distance of 7.5 meter. Ano na to, x bar? Or let's say this is our x1. So para makuha na to ang kaning x2, x3, and x4, so dali rin siya. So let's say this is our x2. So since di ba ang atong x bar is 7.5 gikan sa atong reference column to our centroidal axis, di ba 7.5 ni, then we have a 5 meters nga kaning dere A to B nga column. So i-minus na to. So 7.5 minus 5 meters is equals to 2.5 meters. Muna ni ang atong x2. Muna ni atong x2. This will be our x1 or x bar. So ang pagkuha na to sa x3, di ba ang kanina na distance gikan sa column na B to C is 5. Then i-minus lang na to sa nakuha na to na x2, which is 2.5 to get 2.5 or half lang siya kay mo na itong centroidal axis nya we get the 2.5, then understandable na 2.5 po ni siya. So ang x4 na to is di ba we have a total of 15 gikan sa atong reference column to our last column. 15 ang iyang total distance. Then i-minus lang na to sa atong x bar or x1 to get our x4. Minus 7.5 is equal to 7.5 meters. So nakuha na to ang distances niya. So let's move on sa second assumption. Let's try to explain the second assumption. So the second assumption say the direct stress in the column are proportional to their distances from the centroidal vertical axis of the frame. So according daw to our second assumption, so gikan say sa column A, or let's say this column here, let's denote it as V1, V2, V3, and V4. So therefore, according sa atong second assumption is that V1 over X1 is equal daw sa V2 over X2 is equal to V3 over X3 is also equals to V4 over X4. So this kuan daw kaning ading mga distance is the the distance these are the distances from the column of the centroidal axis. So using the second assumption, we can get the answer. So first thing na atong buhaton is that para makuha ni ang V2, V3, V4, we need to get this in terms of V1. So let's try this here. First step. So taking the first and second column or ratio, V1 over X1 equals V2 over X2. V1 over X1 is equals to V2 over X2. So may lang siya since we have no value sa V1 and we have value sa X1 which is ato x bar, di ba? 7.5 ato lang siyang i-input which is equals to V2. Wala pa tayo value sa V2 which is mao ni atong panggipangita V2. And X2 we have X2 nga value which is 2.5. 2.5. It is equals V2. Input lang nato sa atong calculator. Sige, let's say ito lang isuwat. V1 7.5 times 2.5. So V2 na to is equal to input sa nato sa calculator is equals to 0.33 V1. Mo ni ang atong V2. So dara po to sa V3 in terms of V1. So So taking the first and third issue. So V1 same lang gyapon, copy, equals to V3 over X3, which is equal to copy lang V1 and then X1, natin value sa X1 which is 7.5. 7.5 is equals to V3 which is muna itong ipangita VT, and then X3 na po tayo value same lang gyapon sa value 2.5 which is equal to in process kay na, so V3 is equal to same lang sila value, then yun lang po sila 0.3 V1 ano ito V3, and then sa V4 taking the first and fourth ratio. So copy lang sa V1 over X1 plus V3 over V4 over X4. Sorry. So V1 and X1 natin value 7.5 equals to V4 which is atong ipangita, and then we have a value of X4 which is 7.5 also, which is kung ato siyang i-divide 1 lang siya, so V4 is equals to V1 1 lang siya. So that leads us to our next step, step 2. So itong step 2 ato lang i-copy outro ang mga values kay na. V2 is equals to 0.33 V1, V3 is equals to same lang sila 0.33 V1, then V4 is equals to V1. Manakuha na ito na siya kay na. So sa second step the axial force will get the axial force in the column of story 1. So muna itong story 1, and then according sa atong assumption 1, point of contraflexure occurs at the middle point of the various numbers, which is this one. This is our point of contraflexure. So mag-moment ta sa atong point of contraflexure. So 12, which is this one, gani 12 nga atong lateral na loading, 12 times which is ang atong distance 6 plus 6 12 plus 3 15 plus ang second na load 24 times 6 plus 3 9 plus 48 times the distance 3, and then the vertical load which is the plus V1 times 0 since mas distance, and then plus V2 which is ang atong distance is 5 meters gikan sa atong point of contraflexure 5, then dali na lang plus minus since ang atong direction is going upwards. Sorry, this is minus V3 times 10 which is our atong distance, and then also negative V4 times 15. So as you can see, kaning akong gibutang na V1 V2, V3 nga na yung mga dash, this is implication lang ni siya sa atong first floor, isa ka nidare niya sa second floor duha, and then sa third floor kay tulo na. So implication na sa floors. As you can see, na siya yung mga arrow dire going away and going towards, going downwards, kaning duha niya, kaning duha pod going upwards. Kay di man siya pwedeng isame lang nato siya kay ang lateral loading niya kay padulong dito inya yang atong load kung puro po dire paubos, hindi mag-fail ang kuan. Right. So we need to counteract the force nga na-apply there sa lateral load which is counterclockwise, and then dapat magbuhat ta og kanang reaction na towards counterclockwise kay para ma-counteract and then mag-cancel out lang sila. So moving on, dinote lang nato ni siya as V1 nga first floor ni siya, V2 first floor. Then rewrite nato kay di ba natay anang natay value aning V2 which is kani ato lang na siyang i-rewrite. 12 times 15 plus 24 times 9 plus 48 times 3 plus since times 0 man na 0 na lang na siya diretso, plus which is V2 0.33 V1, and then negative atong V3 0.33 V1 minus itong V4 is V1 times na pa din siya times, I'm sorry, V1 times yung distance nga 10 V1 15 is equals to 0, so which is equal to our V1 is equal to ato lang siya input sa calculator, and then we'll get the answer of 32.43 kilonewton. Ano itong V1? So since natay V1, pwede na to siya makuha ng V2, V3, and V4 kaya ato naman lang ni siyang ibutang dire, input. So getting the V2 is equals to 0.33 V1, or ito siyang idiretso ubot ang input 0.33 times 32.43. So atong V2 input na to siya sa atong calculator, we'll get the answer of 10.70 Newton. Then sa V3 is equals to same lang yapon sila og value man, V1 which is V3 is equals to 10.70 Newton yapon. Then sa V4 which is equals to V1, then understandable na atong V4 is equals to 32.43 kilonewton. So para mahibalaan na to or ma-check na to kung nabatay mali nga nabuhat, so we have a formula for checking kung tama ba niya atong mga gipang buhat. So we have a formula of V1 plus V2 minus V3 plus V4, which is dapat mag-equal siya sa 0. So i-plus na to 32.43 plus 10.73 70, which is 43.13 minus same lang sa lag value 43.13 equals to 0. So tama itong gibuhat. So the next step 3 na ta. Step 3, axial force to the column of the second story. So taking the moment about the point of contraflexure, there is a second story na siya. So well, sa same process lang gyapon gay na 6 iyang distance gikan sa point of contraflexure, kung natong gi kuhaan og moment times 9 plus 24 times 3 plus V1 nga second floor na ako lang yung gisulat times wala ni siya distance, no, nya positive gapon since clockwise. V2 second floor, yung distance is 10 minus kay counterclockwise na siya, rin lang ako ibutang V3 and 4, and then yung distance which is 10 is siya, and then this is the V2, which is 5. I'm sorry, 5. This is 5. And then minus the V4 dash 15 equals 0. So ato na siyang i-rewrite. Input kinama siya yung mga value V1, di ba? So 12 times 9 plus 24. V1 na to is 0 plus V2. V2 is 0.33, no? V1 double dash times 5 minus ang atong V3. Sa yung lang yapon 0 to. V2 ni siya ay V1, I'm sorry, V1 double dash second floor pa man, then minus atong V4, which is V1 ragyapon na double dash is equals to 15 equals 0. So input sa calculator, makuha na to ang V1 double dash sa atong kuan sa second floor. Okay, V1 double prime okay 10.81 kilonewton ating V1. So natay V1, makuha na ito tong V2, V3, V4. So V2 equals to ba natay ko ang gain na kanya ito ibalik, diba? Kanya yung duman ato na siya input ito 0.33 V1 double prime. So V2 is equals to 0.33 times 10.81. So V2 is equal to V2, input na ito sa calculator, which is 3.57 kilonewton. So V3, input na ito diretso 0.33. V1 is equals to same lang gyapon sila og value, same lang gyapon sila og answer 3.57 kilonewton. And the V4 equals to V1 double prime. V4 will be equal to 10.81 kilonewton. Nakuha na itong V4. And then that leads us to the next step, which is step 4 sa actual force in the story 3. So same process lang yapon, taking moment about point of contraflexure ba? Ano niya itong kuhaan sa third floor ni? May contraflexure here. So siyang 12 times 3, diba? 12 yung load, and then from the distance from the contraflexure is 3. So plus V1 low third floor ni siya times 0 yung distance na rin na. Then V2 5 minus V3 and then yung distance minus V4 15 equals to 0 na equals to 0. So input ito lang siya rewrite since naman siya mga value plus 0 na siya V2 plus 0.33 V1 5 minus 0.33 V1 triple prime. So times 10 na nato i-move minus kasi atong V4 is V1 15, diba? Equals to 0. Then we can get the V1 na sa third floor is input na nato siya sa atong calculator, then we can get 2.16 kilonewton. Ano na to? Makuha na po na to itong V2. equal to 0.33 v1 prime v2 ato lang siyang input diretso 0.33 times 2.16 v2 makuha na to itong v2 with a value of 0.71 Newton. So atong V3 lang na to isuat dere. Ay sorry, wala na nakita. V3 is equal to yung process lang yapon siya kagain na is 0.33 V1. So is equal to 0.33 times 2.16 is equal to yung lang yapon sa mas value 0.71. Then sa V4 which is equal to V1, so V4 is equals to 2.16. So moving on sa atong step 5. Step 5 nito. Shear at the end of the beam. So na-notice ninyo, di ba? Ang kane na ako'y na gibutang na arrow. Amplification na siya sa katong distance nga ina nga kane puro down and then this one is upward. So ako lang siyang gibutang na ang kane kada isa, kada point of contraflexure na siya downwards or upwards depends sa iyang column sides. So ato lang timan-an na pag for example magkuha ta sa sa shear dire sa point E. So ang kaning arrow nga pointing away sa point is negative. And then kaning mga arrow na pointing at the point which is positive. Muna natong timanan. So moving on sa shear at E. Shear at E. So is equal to V1 positive ni siya kay pointing man sa E. So I mean V1 nga sa third floor plus kay positive yapon V1 second floor, and then this one since pointing away naman siya sa point minus na siya first floor, diba? Since naman tayo mga value nila atong nasolve kagay na, so atong na siyang input 0.16 plus 10.81 minus 32.43 which is equals to input lang na to 10.46 kilonewton. Ano yung shear at E? So sa shear at F, so same process lang gihapon. Ito na siyang kopyaon, negative 19.46, and then same process, diba? Kani positive niya, kani negative, plus V2 plus V2 second floor minus V2 first floor, so which is equals nanis na yung mga value. So negative 19.46 plus 0.71 plus 3.57 minus 10.7 which is equal to input na siya sa atong calculator, no? Negative 25.88 kilonewton. So sa shear at F, we have the F, shear at G na kanina no, at G copy lang, negative 25.88 plus since mo na itong point, diba? And then ang mga arrows sa second floor and then sa third floor kay going away na, so negative and then mo na positive minus V3 minus V3 second floor plus V3 first floor. Input lang nato ang yang value. Negative 25.88 minus 0.71 minus 3.57 plus 10.70. Diba? So, makuha na nato answer which is negative 19.46. So, dara na punta sa H, di ba? Here at H. So, copy lang gyapon, same process lang gyapon. Minus ni siya. V4 minus V4 na second floor plus V4 na first floor is equals to negative 19.46. Ano siya yung mga value? Again na. So, kung 19.46 minus 2.16 minus 10.81 plus 32.43, which is kung ato na siyang i-input equals to 0 na siya, diba? Then next, here at I here J, K, L kanina po sa second floor. So here at J, I is V1 third floor minus V1 second floor, diba? Kani going away, kani going towards the point. So muna yung positive, kani negative, is equal to 2.16 minus 10.81. So we can get the negative 8.65 kilonewton. So share at J. Copy lang, same process lang gyapon. Same process plus, say minus, since minus man is siya. Going away, then going towards. Share at J. So plus na siya, sorry, plus V3 third floor minus V3 second floor, right? V2 na siya, V2, sorry, which is equal to negative 8.65 plus 0.71 minus 3.57, which is equal to negative 11.51. So here at K, kanina dere ina. So diretso na nato, input na negative 11.51, and then minus 0.71 plus 3.87 na mga value niya, we can get niya 8.65. Then sa here at L, dere here at L, input na po nato diretso, no? Copy lang ato answer yay na negative 8.65 minus 2.16 plus 10.81 is equal to 0. So next step, continuation pa di ay sa sa kaning dere sa atong M o N O and P. Shear at M equal to, then sa negative ni siya kay going na this is our point and then the arrow is going away. Kani negative, negative, positive, positive. Negative V1 third floor is equal to negative 2.16 per Newton. So sa N equal to, copy lang yan, 2.16, and then minus atong V2 na third floor equals to 2.16 minus 0.71, which is equal to negative 2.87. Then sa O, diretso na to, 2.87 minus, plus na to siya, plus na ni siya ay this is the point niya, ang arrow padulong sa point, plus na siya, plus 0.71 is equal to negative 2.16. So sa last P, shear at P, negative 2.16 plus 2.16, which is equals to 0. That leads to our final step. Step 6, moment in beam. So to get the moment in the beam, moment EF, so ato lang siyang buhaton is itong shear nga atong nakuha multiplied by the half of span of the beam. So ano siya, the shear times half of span of beam. So sa moment EF, di ba natin nakuha na negative 19.46 times na nato sa iyang span, di ba? 5 to siya, 5, which is wait lang, which is EF, this is E, this is F, di ba? 5, yeah, 5, 5, 5. So moving on, type lang natin sa itong calculator, we can get 4.65 kilonewton meter. Then sa moment FG, so we have negative 25.86. Same process lang ni siya tanan, we can get 64.7 kilonewton meter. Then moment at GF equals to negative 19.46 times 5 over 2, which is equal to negative 48.65 kilonewton per meter. So moment at IJ, negative 8.65 times half of the span, which is negative 21.62 kilonewton meter. So moment at JK is equals to negative 11.51 times 5 over 2. Then get the answer, negative 28.77 kilonewton meter. The moment at AL is equal to negative 8.65 times half of the span. We can get negative 21.62 Newton meter. So moment at mn. Negative 2.16 times 5/2. You can get negative 5.4 Newton meter. Moment at NO negative 2.87 times 5/2 equals to negative 7.17 kilonewton meter. Then slash moment O P negative 2.16 times half of the span lang, negative 5.4 kilonewton meter. So na-notice ninyo nga itong mga nakuha na to na mga diba natay 0 here nga 0 pod sa L na shear, wala na to i-appeal dali no kay 0 ang gyapon siya. So that concludes our discussion. Thank you for listening. God bless. So continuation, another example for the cantilever method. So as you can see in our frame here, first step, we have to determine our centroidal axis, and we have to assume that this is our centroidal axis, this one here, and from our reference point, which is this one, to our centroidal axis we have a x bar. And as the previous example, we have to assume that all the column has the same cross-sectional areas. So since we have 4 columns, and according to Varington's theorem, I'm gonna put it down here for a x bar is equal to a times the distance. Since itong first column is our reference point niya, wala siya distance, 0 na siya, plus our next column from the distance from our reference column is 20. Then next is 20 plus 15, 35 plus a times 20 plus 15 plus 25 is 60. Then input lang na to sa atong calculator, and we'll have an x bar which is 28.75. Then next one, let's say this is I forgot x2, and from our reference point to our third column is x3, and from our reference point to our last column is x4, and let's say this is x bar is x1. So since we have x bar or x1, we can get x2, x3, and x4. So in order to get x2, it's just 1 lang. Since di ba natin x1, nakuha natin siya sa x2, right? Okay, atong x1 which is 28.75 minus sa atong column A to B, so that we can get x2. So 28.75 minus 20 is equals to 8.75, which is ang atong x2 here, x3. Since we have a kuandare natay distance from B to C, and half sa atong which is our centroidal axis nya natay value sa x2, minus lang na to, 15 minus x2, so equals to 6.25. then x4. Since atong x4, since we have a total of 60 meters na distance, then we'll just have to minus the total distance atong x4 para makuha na atong x4, which is 28.75. I mean 60 minus 28.75, which is 31.25. So nakuha na itong mga value. Then let's proceed sa katong as you can remember sa atong second assumption, which is I'm gonna put it here na lang ato ning previous example. So the direct stress in the column are proportional to their distances from the centroidal vertical axis of the frame, right? So ang iyang pasabot daw dere is, so ato lang ni siyang i-denote as kanina column kani o kani as this one V1 first floor atay dashi butang dera, V2 first floor assumption identification lang ni for the floor, so V3 first floor na V4 first floor. So according sa atong second assumption is that V1 over X1 is equal to V2 over X2 is equal to V3 over X3 is equal to V4 over X4. So we will get V2, V3, V4 in terms of V1. So first, kaunsa na to ang V2 in terms of V1. V1 over X1 equals V2 over X2. Then ato lang din siyang i-kuhan kay ang atong kaon is V2 man. V2 is equals to V1 over ang atong value sa X1 is 28.75 times the value of our X2, which is 8.75. Then we will get an answer of 0.304 V1. This is our V2. Then we'll get V3 in terms of V1. Copy lang gihapon. Same. So we'll get V3 in terms of V1. So same procedure lang gihapon. V3 equal to V1, which is ang atong value sa X1 is 28.75 times the value of our X3, which is 6.25. Then input sa calculator, we'll get the answer of 0.217 V1. Same lang gyapon sa V4 in terms of V1. Copy lang. Then multiply sa atong X4, which is 31.25. Then we'll get an answer. V4 is equal to 1.086 V1. Then we'll move on to our second step. This one here. So sa atong second step, we'll get the actual force in the column of the first story. This one here, and we have a point of contraflexion. So first na atong buhaton dere is let's take a moment about the point of contraflexure. So, I forgot. You have 8 kilonewton and then 10 here. So 8 times this 8 auto lateral load times the distance 12 plus 8, which is 20, then plus 10 times the distance 8 plus iba to na siyang gininote yain na as V1 first floor, V2 first floor, V3 first floor, V4 first floor. So plus V1 times 0 since na atong point of contraflexion dire, then wala siya distance, and plus V2 first floor times the distance, which is 20, plus V3 first floor times the distance 35. Minus ni siya. I'm sorry, since counterclockwise ang iyang since upward mo ni siya. Negative minus V4 first floor times 60, which is the distance, then input I forgot na nabiya tay value aning V2, V3, V4 na ato nakuha na, which is ato lang siyang i-input. 20 plus 10 times 8 plus 0 since times 0 na siya, plus 0.304 V1 times the distance 20 minus 0.217 V1 times 35 minus 1.086 V1 times 60 equals to 0. So by inputting the calculator natin makuha. So by inputting V1 in the calculator, you'll get the answer of 3.59. Then sa V2, which is kanina itong V2 0.304 V1 times lang ito sa 3.59, we'll get the answer of 1.09. Itong V3 0.217 times 3.59, then we'll get the answer of 0.78. Then sa itong V4 1.086 V1 times 3.59, we'll get the answer of 3.19. So by checking kung tama atong nakuha, checking V1 plus V2 minus V3 plus V4, which will get the answer of 0. So 3.59 plus 1.09 minus 0.78 plus 3.90 input sa calculator 0. So tama ito nakuha. So sa third step, kuha niya pa na itong actual force in the column but in the second story na. So same process lang gihapon dere. Natay load dere na 8 kilonewton. So 8 times distance 6 plus V1 at the second floor, V1 second floor, V2 second floor, V3 second floor, V4 second floor, V1 times 0 since 0 yung distance, since naman itong itong point of contraflexure. So plus V2 times 20 minus since counterclockwise V3 second floor times distance 35 minus V4 second floor times the distance 60 is equals to 0. So i-write lang nato since naman siya yung mga value V2, V3, V4 plus 0 plus yung V2 which which is 0.304 V2. I mean V1. I'm sorry, V1. And then minus itong V3 na 0.217 V1 second floor minus 1.086 V1 second floor. I forgot the distances. 20, 35, then 60 equals to 0. Then by inputting, we'll get the answer. V1 at second floor equal to 0.71. Then sa V2 second floor, which is 0.304 times 0.71 or 0.21. So V3 0.217 times 0.71 equals to 0.15. Then V4 equal to 1.086 times 0.71 equals 0.77. So these are values na magamit na to niya. So step 4, which is this one. So we'll get the shear. So first here atong E, we'll get the shear at E. So shear at E. Sorry, here at E, which is equal to V1. Kung na-recall pa ito akong result kung atong base dere, atong base ng shear sa E. So anything nga point away sa atong E is negative, and then katong the point towards atong point E is positive. So since V1 second floor positive siya, and then sa V1 which is going away from the point is minus V1 first floor. So by inputting equal to atong V1 na second floor is 0.71 minus atong V1 na first floor which is 3.59, which is equal to negative 2.88. Then here at F, dari na punta siya at F. So copy lang, negative 2.88, then plus V2 second floor minus V2 first floor, which is equals to negative 2.88 plus 0.21 minus 1.09 is equal to negative 3.76. Then shear at G. Ayan punta. So copy lang ang 3.76 minus minus na siya kaya ang V3 is itong point sa G is going away from the point. So si V3 na second floor is negative, then positive si V3 na first floor kaya going towards just point. V3 positive is equal to negative 3.76 minus 0.15 plus 0.78, which is equal to negative 3.13. So shear at H, equal to copy lang, negative 3.13 minus V4 second floor plus V4 na first floor, which is 13. Ato siyang i-input ang mga value which is nakuha na ito kagay na 0.77 plus 3.90 is equal to 0. So shear at I, na rin na po. Shear at I equal to negative siya kay since mo niya tong point here niya itong arrow, so V1 second floor is going away. v1 second for is equal to negative 0.71, which is atong v1 second for gaina na nakuha. So siya input, then shear at J is 0.71 minus v2 second for, which is equal to negative 0.71 minus 0.21 is equal to 0.92. So shear at K. So shear at K, copy lang, same process lang yapon, plus na ni siya kay this is our point here, then arrow na to from V3 second floor is going towards so 0.15, which is equal to negative 0.77. Then shear at L is equal to negative 0.77. So shear at L, copy lang, negative 0.77 plus itong V4 gain second for which is 0.77 is equal to 0. So last step atong on is moment in beam. So here, so last step is the moment in beam. Say step 5. So moment and EF. Sorry, this one. So in order to get the moment and EF, just have to put the input, to input the answer na tagay na, which is negative 2.88. 2.88 times half of the span of EF, which is 20 meter. Then here is 15 meter. Then here is 25 meter. 20 meter over 2 is equal to negative 28.8 kilonewton meter. So moment FG, beam FG, which is here to here with a 15 meter distance. So we get that 8.76 times the distance 15 over 2, which is equal to 8.2 kilonewton meter. Then moment GH equal to 3.13 times half of the span, which is 25 over 2, equal to 39.125 kilonewton meter. So this is the first story, and this one at IJ na beam here, which is 0.71 here, as you can see, times the distance half of the span, which is 20 over 2, is equal to 7.1 kilonewton meter. Then moment at beam JK is 0.92. You can see here, times half of this one, which is 15 over 2. Input sa calculator, we'll get the answer of 6.9 kilonewton meter. And last, beam KL, which is 0.77 times half of the span, which is 25 over 2, equal to 9.625 kilonewton meter. And that concludes my discussion.
Hello everyone, my name is John Lloyd L. Hilo. So today we will discuss about the moment distribution method. The definition of the moment distribution method So it is a structural analysis based on the method of successive approximation developed by Hardy-Cross in 1885 to 1959. This method is applicable to all types of rigid frame analysis. So the steps to solve the moment distribution method is first is the relative stiffness. So K equals to I over L. So if far end of member is fixed, then if the far end of member is hinged, you can use 3 over 4 times I over L. For example, so as you can see in this graph, no? So using slope deflection equation M and F, M theta n equals to theta f equals to fixed end moment equals 0. So M equals to 4ei over L times theta. So bending stiffness, so K bar sec theta equals 1 rad. So K bar equals to 4ai EI over L. So the relative stiffness equation is that K equals to K bar over 4E equals to I over L. So next, the distribution factor. So the distribution factor equals to K. So change of K, if the joints have 2 or more members. If equals 0 ang distribution factor, it means fix ya. Kung pin or roller, the distribution factor is equal to 1. For example, as you can see in the graph in illustration, so KBA equals to KCA equals to I over 20 equals 0.05 I. Then KBD equals 3 over 4 times I over 30 equals 0.025 I. So to get the distribution factor, so let's get first the joint AB. So DFBA equals to KBA over KBA plus KBC plus KBD, no? To get the answer, you need to divide KBA to the added value of KBA, KBC, and KBD. So equals to 0.4. So the next is the joint BC. So DFBC equals to KBC over KBA plus KBC plus KBD equals to 0.4. So DFBD. So KBD over KBA plus KBC plus KBD equals 0.2. So next step, so is the carryover moment, equals to M over 2. So M and F equals to MBA. Theta F equals to theta. Theta N equals to fixed end moment, NF equals to 0. So therefore, MBA equals to 2EI over L theta. So N equals to 4EI over L theta. So theta times ML over 4EI. So MBA equals to M over 2. The final answer. So next, fixed end moment. So if uniform load siya, you can use this formula. So WL squared over 12. So they are both equal, no, sa at their ends. So ang pikas ana kay negative kina siya, negative WL squared over 12. Next, if ang iyang external load is nasa center, so you can use the formula PL over 8. If ang exterior load nimo is nasa sa mga far end, so you can use PAB squared over L squared. Then the last step, because of sign convention. So let's go over the example. The first example. So example number 1. So determine member and moments. So we have given I equals to 1,500 inch to the 4th power and E equals to 29,000 KSI. So this is our illustration. Ang first step nato is buhaton is to get the relative stiffness, no? So we need to get the relative stiffness first. So first want to get is the joint AB. Joint AB equals to KAB. Then equals to IAB over L. Since fixed man siya, atong gamiton niya formula is atong I over L. So equals our I equals to 1,500 inch for over atong L equals to 20 feet. The answer is 75 inch for per feet. Wala siya itong KAB. Sunod, ang next na tupaon is ang joint BC. So KBC equals to IBC over LBC. Since pareha naman sila og kuan, nga na siya. So 1,500 inch 4 over 20 feet equals to 75 inch 4 over feet. Yun na siya. So lastly, ang atong joint CD, KCD equals to ICD over LCD equals to 1,500 inch 4 over 15 inches feet equals to, so our answer is 100 inch over feet. So nakuha na natin tanan ang relative stiffness niya. Next thing to do is get the distribution factor. So distribution factor. Since fixed man siya, so DF equals 0. Then first thing to solve is the joint B. Then DF BA equals to KBA over KBA plus KBC. X equals to, ang KBA na to is 75 inch 4 per feet While at 1, KBA out of 1. I-add na to ang KBA of KBC. So, 75 plus 75. Mahimo na siya og 75 plus 75 inch for per feet. So, cancel. Answer is 1 over 2. Next one. DF ang BC na to. BC. So, KBC over KBA plus KBC. So, same na naman sila. So, pwede rin i-drate sa natin no? 1 over 2. Answer. Nagta sa joint C. Joint C. So, DF CB equals to KCB over KCB plus KCD equals to ilan man natong KCB, so 75 over KCB plus KCD, so 175 equals to 3 over 7. Lastly, ang DF's distribution factor joint CD goes to KCD over KCB plus KCD goes to 100 over 175 equals to 4 over 7. So yeah. So, next thing na tong abuhaton is to get the fixed end moment. So, sa fixed end moment AB, sa joint AB, since man to siya, no? Uniform, so we can use the formula WL squared over 2 ay over 12 siya. So FEM AB equals to matungguan W is 1.5 times length equals to 20 squared over all over 12. So answer na to is 50 kilo per feet. So ang pikas anak niya, since pareha naman na sila, ang kuan lang niya buhaton lang niya is ang answer sa FEM AB equals A negative lang, so no, FEM BA equals to negative 50 kilo per feet. Siya. So next, kuha na to is ang joint BC. No, joint BC tong nga. Yan na siya. Nga naman to siya ang joint BC. So we can use PL over 8 formula. So FEM BC equals to 30 times 20 length, 30 ang kuha niya, load over 8 equals to 75 kilo per feet. Next is to get other one. So FEM CB, negative lang po na siya 75, negative 75 kilo per feet. So ang joint CD na to, no, FEM CD since wala man siya external load, ang buhaton na to ana mahimo na siya 0. Mahimo na siya answer ng 0. So next, nakuha naman nato na sino ang final fixed end moment. Mag-graph na magkuha na rin ta dayon, mag-table na rin ta. Table ta. So table ta. Let's make a table. This is A, this is B, C, and D. So this is the joints DF. So our distribution factor 0, 1 over 2, 1 over 2, 3 over 7, 4 over 7, then 0. So next thing to do is to fill the fixed end moment, which is the first one 50, negative 50 ang FBC, FEMBC equals to 75. Ang FEMCB, so negative 75. So ang FEMCD 0, ang FEMDC is 0 also. So what we're gonna do now is to balance. Let's balance. First one is 50 times 0. So 0 siya. Kani ang kinahanglan ani dito para ma-balance di siya is 25. So tungaon ng 25 since natunga siya para makuan, bantay sila. Nahimo na siya og 12.5 and 12.5 since kuha mo sila. So diri sa 1 diri sa 75. So ang need nimo is negative. So ang need nimo is negative 75. Ay positive, need nimo positive 75. So you need so 3 over 7 times 75. So it is 32.14. Then 4 over 7 times 75. Answer is 42.86. Then 0 times 0 equals to 0. Next thing to do is to carry over moment. Carry over. So, nga ni siya pagkuano, pag-carry over nga ni on. So, 12.5 negative. Then, tingnan po siya dere. 0 sa pikas pod. Negative 12.5. Then, kani naog dere 32.14. Tripod 42.86. Then lastly 0. So para makuha na to yung final end moment, no, pagamayon na to sa hagsamot para makuha yung final end moment. So balik-balikon lang nimo siya, no, balance and carry over moment. Balance na pug ka. So 0. So you need negative 16 point, so 32.14 mo siya. di siya di ay 16.07, negative 6.25. Ito ko na to. Okay, murag mali siya. Katungon din mo dahil pag carry over, negative 6.25, negative 16.07, negative 6.25, and 21.43. Next thing to do is balance. This is 0, and so wala mabalance siya. Itong buhaton is i-half ning 16.07. Ang half na niya is negative 8.04. Ikas po negative 8.04. And dire, so 3 over 7 times negative 6.25. 2.68. Bigas po 4 over 7 times, mahimo na siya 3.57. So 3 at is 0. Then carry over. So carry over ang half niya goes to negative 4.02, 0, negative 4.02, because is 1.34. Diri ito nga niya is 1.79 and 0. Next, balance na punta. No, balance na punta. It is 0. So 1.54. Half niya equals to negative 0.67 because 0.67. Dire, 3 over 7 times negative 4.02 equals to 1.72. So 4 over 7 times 4.02 equals to 2.30 and 0. So carry over na punta. Carry over. Carry over na punta. Half niya is 0.36. 0, negative 0.36, 0.86, 1.15 and 0. So, balance na po. So let's balance again. So 0.86 ito nga equals to negative 0.43. 0.43 because 3 over 7, 15. Because so for 4 over 7 times 0.34, so 0.19 and 0. So pwede na siya. Since kamay naman siya, pwede na ito siya i-total. So to get the final and moment. The first one equals to 50. Data so good. 50 minus 6.25 minus 4.02 minus 0.36 equals to 39.4. The next one, so negative 50 minus 12.5 minus 8.04 minus 0.67 minus 0.43. The answer is 71, negative 71.6. The next one, 75 minus 12.5 minus plus 16.07 minus 8.06 minus 1.34 plus 1.34 minus 0.67 plus 0.86 minus 0.43. The answer is same sila, no? 71.6. Dari was negative 75 plus 32.14 minus 6.25 plus 2.68 minus 4.02 plus 1.72 minus 0.34 plus 0.15 equals to negative 48.9. So 0 plus 42.86 plus 3.57 plus 2.30 plus 0.19 equals to 48.9. So lastly, 0 plus 21.43 plus 1.79 plus 1.15 equals to 24.4. So mo ni siya imong final end moment. Mo ni siya. So next example, determine member end moments. So given I equals to 3,000 inch for and E equals to 48,000 KSI. So mo na siyang illustration sa atong solvent karon. Example number 2. So first thing again to do is to get the relative stiffness. Okay, relative stiffness. So since 6 mangyapon siya on both ends. So first thing to do is to get the joint AB equals to IAB over LAB. So 3,000 over 30 equals to 100 inch for per feet. So next is to KBC equals to 3,000 over 30, same, so 100 inch for per feet. Next is to KCD equals to 3,000 over 20 equals to 150 inch for over feet. And next it was to get the distribution factor. So since mo naman yaman siya, alihara sila nga x, no? So 0 yaman na siya. So first is the joint BA. So KBA over KBA plus KBC equals to 100 plus over 200 equals to 1 over 2 sa joint B niya. So next equals to DFBC equals same naman sila, so 1 over 2 lang gihapon yung siyang answer. So dili na ta sa joint C. DF C CB equals to ACB over ACB plus ACD equals to 100 over 250 equals 2 over 5. So joint CD equals to ACD over KCB plus KCD. KCD is 150 over 250. So answer is 3 over 5. Next, we will get the fix and moment. So C, fix and moment. First one is katong WL squared. This is the first one. So the joint AB. So ang gamito na itong formula is WL squared over 2. The other one is WL squared negative WL squared over 12. So FEM AB equals to the W3 times 30 squared over 12 equals to 225 kilo per feet. Same lang sila, no? Same lang sila. So iato lang yung negative ang FEM BA moment at BA, fixed and moment at BA. So negative 225 kilo per feet. Next one. So fixed and moment at BC. Get the fixed and moment at BC. Siya PL over 8 negative PL over 8. So fixed and moment at BC was 2 ang atong kuan is 90 times 30 over 8 equals to 337.5. Then the FEM CB equals to negative PL over 8 and negative 90 times 30 over 8 equals to negative 337.5. Yeah. Next is the joint CD. Joint CD na ta. Joint CD. So A, B, and L. So yan siya. So PAB squared over L squared, and the other one equals negative PAB squared over L squared. So the first one to get is the FE, final end moment, fixed end moment CD equals to 80 times 8 times 12 squared over 20 squared. So ang FEM CD equals to 230.4. So ang FEM CD na to is negative 230.4. Wala na siya. Then nakuha na natin sa tanan. So sunod buhaton is mag-graph na ta. Graph na ta. 30. So distribution factor. Zero, 1/2, 1/2, 2/5, 3/5, then 0. So next, set ang table ha. So next thing is to put the fixed end moments. 2225, negative 225, 337.5, negative 337.5, 230.4, and lastly negative 230.4. Ang button na to is to balance. Balance ta. Same thing to do, no? Pag-amayin na to para makuha na to ang final end mode. So, balance 0. So, katunga nila, ang kulang nila is 56.25. And I mean, tama. So, 100 iyang kulang, 100 ka pin. So, patungaon na to ng 5 equals to 56.25. Negative 56.25. Other one. So, negative 42.84. Then 64.26. Then 0. So, carry over moment. Moment niya negative 28.125, 0, negative 28.125, then 21.42, 32.13, 0. Let's balance 0. Ito nga sa 21.42 equals to 10.71. Negative 10.71 because 71 yap. Negative 10.71 yapon. Ito rin, negative 28.125 divided by 2/5 equals to 11.25 sa pikas times 3/5 equals to 16.875, then 0. Then carry over moment katunga sa 10.71 equals to 5.355, negative 5.355, then 0, negative 5.355, then 5.625. Here's because 8.4375, then 0. Then balance na punta. Huwag na ito phone box kulang. Balance 0 patungo sa 5.625 equals to negative 2.8125. So negative 5.355 times 2 over 5 equals to 2.142. The next one. Next, 8 times na po siya 3 over 5 equals to 3.213 and 0. So, carry over moment na punta. Ito nga sa negative 2.8125 equals to 1.4625 and 0. So, ito nga yapon negative 1.4625 atong sa 2.142 equals to 1.071. Then ito nga sa 3.213 equals to 1.6065 and 0. Balance na po. Balance na po tayo. 0. 1.071 kato nga. Mas negative 5355. That is 0.5355. Then negative 1.4625 times 2 over 5 equals to 0.5625. So because 0. Same sila. So 0.84375 then 0. So since gagmay naman siya, so we can get now the final end moments. So the final end moment. So add na to siya. 225 minus 28.125 minus 5.355 minus 1.4625 equals to 190.11375. Next one, negative 225 minus 56.25 minus 10.71 minus 2.8125 minus 0.5355 equals to negative 295.308. So next one, 337.5 minus 56.25 plus 21.42 minus 10.71 plus 5.625 minus 2.8125 plus 1.071 minus 0.5355 equals to same sigapon, same, and positive lang siya. 295.308. Next, negative 337.5 minus plus 42.84 minus 28.125 plus 11.25 minus 5.355 plus 2.142 minus 1.4625 plus 0.56225 equals to negative 315.59175. Same sa bikas, pareha naman silang akuan joints, so moragya mo sila kasi pareha ra and nakalain lang sila og ilang sign 315.59175. Then lastly, negative 230.4 plus 32.13 plus 8.4375 plus 1.6065. And we will get 188.226. So this is the final end moment that we got. So That's all for my discussion. I hope you understand. Thank you. Bye.
Good day, everyone. My name is Christian G. Mandugnahan, and I'm going to discuss the portal method.
Portal method is an approximate analysis used for analyzing building frames subjected to lateral loading. So portal method has three assumptions. First is point of inflection at the center of each girder. So meaning, if you have a beam, the point of inflection is at the center. Number 2, point of inflection at the center of each column. So if we have a column, the point of inflection is at the center. Number 3, the total horizontal shear on each story is divided between the columns of the story, so that each interior column carries twice as much shear as each exterior column. So meaning, if we have a one-story building, so this is the exterior column and interior column and exterior column, so that each interior column carries twice, so meaning as much shear as each exterior, so meaning the exterior has a single shear and the interior column is twice as much shear as exterior, so multiply by 2, that would be 2 shear, and the exterior also 1 shear. So that's all. Let's proceed to the example. So in this example, we have a one-story building, and we must know the 4 steps on the portal method. So first, we must determine the column shear. Number 2, column moment. Number 3, girder moment. And number 4, girder shear. So here, the one-story building has a width of 4 meters, and the height is 4 meters. And the horizontal shear is 10 kN, kilonewton. First, so in my previous example, in the third assumptions of portal method, so each interior column carries twice as much shear as each exterior column. So here we have single shear, and the interior has twice the shear, and the exterior is single shear. So we must first get the column shear. So we must add the shears. So 1, 2, 3, 4. So 4 shears. And we have our load, horizontal load is 10 kN. And we divide it to 4. So therefore, our shear is 2.5. And our twice the shear is 5 kilonewton. So we put the value of the shear, which is 2.5 kilonewton. Twice the shear is 5 kilonewton. The same goes here. 2.5 kilonewton. We can put the shear in the middle or in the center of each column. Here. So we're done in the column shear. So we have to get the column moment. So in the column moment, we have to put moment that is counterclockwise in the column, in the interior and exterior column. So we must get the half of the height of the building. So the half of 4 is 2 meters. And we must multiply it to the shear and with the half of the height of the column or building. So 2 times 2.5 is 5 kN per meter. So same goes here. The lower column also 5 meter. And the interior column we must multiply it by the half of the height. 2 times 5, 10. 10 kilonewton meter. And same goes here. 2.5 times 2, 5 kilonewton meter. So anong say man sila? So isa raman sila og rotation. Same lang sila og value. And we must proceed to third step, which is girder moment. So in the girder moment, we must put a moment in the girder or horizontal beam, the beam. So in the girder moment, we must put clockwise in the beam, horizontal beam. Yeah. So here, we must simply copy the value in the vertical column. So 5K in meter. 5K in meter. So after we're done here, we must know on how to get the value in here in the next moment of the beam. So first is, if this is the beam and the column and the moment 5K and 10K and meter. So what we're gonna do is to subtract if kani gyud yung forma sa, if you have one horizontal beam and one vertical column, so kailangan nimo siya i-subtract to get the value sa next moment. So 5 minus 10 is 5K. So we're gonna put 5K in here. Same goes here. So on the other hand, if you have one vertical column and you have a beam here in the middle, so if the value is 5 5K here meter, so you wanna add it if you have one vertical column. You simply add or plus the value in the moment of the beam. So 5 plus 5 equals 10. If you have cross section or one vertical and one horizontal, the value here so we have one vertical and one horizontal. So first you must follow this step first. You will add the value in the vertical, then you will subtract, and the total of this value is you will subtract it to the horizontal moment. In order to know or in order to get the answer. So 5 plus 5 plus 10 minus 5, so 5K. So we're done in the girder moment. Let's proceed to girder shear. So girder shear, dire ibutang first ang shear sa point of inflection So point of inflection is at the center of the girder. So in order to get the value in the girder shear, we must add the girder moment and divide it to the 4 meters. So 5 plus 5 equals 10. 10 divided 4 equals 2.5. So 2.5 kilonewton. And this one we'll do the same. So just add the 5 kN meter and 5 kN meter and divide it to 4 meter. 2.5 still 2.5 kN. And we're done with the 4th step. So in this next example, it is a 2-story building. So I put the horizontal load and the shears, the height and the width. So first, we must get the column shear. The column shear has the interior column has single shear, exterior twice the shear, and the interior has single shear. Same goes in the below of the building. Now we must add the shears. So 1, 2, 3, 4, 5, 6. So 6 shear. And the horizontal load is 60 kilonewton. Divide it with 6. That. So our shear is 10 kilonewton. And the twice of the shear is 20 kilonewton. And you will input the value of the single shear. Okay. So after we're done here, first we must put the summation in order to get the value on the ground floor. So first we must add the 60 kN and the 90 kN. So we have 6 shears divided by 6. Our shear is 25. kN. And twice the shear is 50. So let's proceed to the next step, which is step number 2 is column moment. We must put counterclockwise in each column. So after we're done, we must divide by 2 with the height of the building. So 6 is half of 3 meters. So we must multiply the shear and the 3 meters. So 3 meters times 10 is 30 kN. Here we have twice the shear, so 20 times 3 is 60 kN. So we're done in the second step, so we must proceed to the third step. So we must proceed to the third step, which is the girder moment. So the column and the girders, the first column and the girder column value is same with the column vertical column. So we must do is to subtract the vertical and the horizontal value. So 30 minus 60 is 30 kN meter. kN meter. Same goes here. So after we're done here, let's proceed to the first floor. So the half of 6 is 3. Multiply it by 25. And 25 times 3, 75. First two. So 3 times 25 is 75. $50 times 3. 150 kN meter. kN meter. And after we're done getting the column moment, we must get the girder moment. So we have one vertical. We must add the 30 and the 75. 105. kN meter. 105 kN meter. So here we have one vertical and half of horizontal. So first we must add a 60 and 150. 210 minus this value, 105. Same lang. Okay, 105 kn. 105 kn. So after we're done in the girder moment, let's proceed to the fourth step, which is girder shear. Let's first put the girder shear. So in order to get that value, in the fourth step, girder shear, we must add the value of the horizontal moment, the horizontal column, girder beam, or the moment of the beam. So 30 plus 30, 60 divide 4, 15. Sorry, divide to 30 kn. So here 30 plus 30, 60 divide 4, 15 kn. 30, 60 divide 6, so 10 kn. Let's proceed to the first floor. 105, so 105, 210 divide 2. Still 105. kn. 210 divide 4, 52.5. And 110 divide 6, 35. 35 kn. And we're done. So this is all of the 4 steps you must know in order to calculate the portal method. So that's all. Thank you.
So good day, my name is Manuel Arquisico, and I'll be discussing the three-moment equation. I am from section 3. So, three-moment equation. Three-moment equation gives us the relation between the moments between any 3 points in a beam and their relative vertical distances or deviation. This method is widely used in finding the reaction in a continuous beam. So, three-moment equation is usually used in a continuous beam, and in using three-moment equation, you get the direct moment, is dili na siya dili na makuha ang slope and the deflection. So based sa equation, direct moment dahil ang atong makuha o masolve. So we had is simply supported beam here. Then we have a nonlinear loading. So it says states na moments at any 3 points. So we put point 1, point 2, and point 3 here. Then we draw the elastic curve. Tapos we drew the axis in a point 2. So we'll get the division H1 and division H3. By the way, sa point 2, di na siya maximum deflection. So, okay, we on the two adjacent span, so ang span between 1, 2, and 2, 3 is considered as L1 and L2. So, ato na siya kuha. Then, we have consider this at 1.12 and 2, 3. So, ano sa 1, 2? So, nasa yung moment 1 pa clockwise, then internal loading, nonlinear loading, M2 nga counterclockwise. So, shear 1, shear 2 prime, L1. So, ano siya, isang moment diagram. Basically, siya shear moment diagram. So, muna siya yung shear. So, nga nila yung result sa moment. So, pa up, then pa minus. Then some moment, we call this moment diagram of the due to internal moment. This one. So M1, so add na tong M1, which is clockwise motion. Then i-minus din ang sa shear diagram. Then we have minus din ang sa M2 pa down. Then sa second na we have M2, same lang, clockwise, counterclockwise. We have shear 2, double prime. So if we add these two, ano siyang direction sa point 2, shear sa point 2. Ato mo siyang gitungan, duwa ka shear. Plus we have shear 3. So same lang here, shear moment there. Then there is a moment diagram due to internal moment. So F2. So pa-add ni siya yung shear, then minus din ng moment 3. So tapos we will use the area moment method. So sa area moment method, we have elastic curve. So atong gibutang point 1, point 2, point 3. Dayon atong gibutang tangent at point 2. And axis along point 2. So we also have H1, H3, then makuha na to si division at division 1 with respect to 2. So there, from here to here. So then division 3 with respect to 2. So So in order to get the similar triangle, so we had this. In order to have a ratio proportion, we get the similar triangle. So we also have length 1 here, length 1, length 2, from point 1 to point from point 1 to point 2 and point 2 to point 3. So we can have a rational proportion. So h1 and h1 minus division 1 with respect to 2 over L1 equals division 3 division 3 minus division 3 with respect to 2 minus h3 over L2. So dion we will use the area moment formula and division formula, which is so area moment method formula, so division formula, which is t let's use this one, equal area forgot area 1 2 x1. So kung ano itong area moment, then para makuha ang area, may tanong pa natin ang centroid here, which is a bar 1, a bar 1, and then what's it, b bar 1. So here, since ginagawa ang trapezoid, we will ang ano to as dua ka triangles. So ang here is ang centroid here is 1/3. Here is 2/3. 1/3 L1, 2/3 L1. Here. So siya, then same here, a bar 2 plus b 2 bar, same sa delay on. So 2/3 delay, 2/3 pa, yeah, 2/3 L2, then the delay is 1/3. Right? May pabali din. So 1/3 din. There we go. Error. So in continuation, so paano to ang division 1 due to 2. So dua ka buo, 1, 2, so multiply lang these two, area 1 and a bar 1, 1 times e power 1 plus this one, dalawang triangle. So 1 half m1 l1 times 1/3 l1 plus 1, wait, so 1 half, and then this one 1 half m2, sa moment 2 m2 l1 then the 2/3 2/3 so this is 2/3 l1, then times I e moment inertia. Simplify, so multiply this 1 half 1/3 e, so 1/6 m1 l1 squared, so multiply l1 plus 1/3 plus 1 multiply m2 and l1 squared plus a1 a bar 1. That's it. And then analyze 1/6 ei times m1 times l1 squared plus 2 m2 2 plus 6 a1 a. So i-multiply siya sa 6, this one. Then next we'll get the division on 3 due to 2. So formula for that, E area 2 3 x 3. So there's not enough space, so let's go down. Yeah. So t here na. So t 3 2 equals IE times this one, so A2 times B2 2 bar plus 1 half M1 L, then the 1/3 of this one is M2, 1/3 L2 plus 1 half of the M2, the other half L2 2/3. Is it? Yeah. Wait, 2/3 muna, plus 1/3 dito. L2. Yan. This is so to simplify, so similar lang, A2 B2 bar plus multiply this one as well, so 1/3 M1 I mean M2 m2 L2 squared plus like this, tapos ang L2 1 over 6 m2 L2 squared, tapos 2 equals 6 multiply both sides are 6, yeah, so 2m2 L2 squared plus m oh mali, wait, oh yeah, forgot this m3, this one, which one, yeah, the 1/3, it's the 1/3, oh wait, 2/3 and 2, yeah, m3 is 1/3, yeah, this one 1/3 m3, so 2 squared m3, yeah, multiple 6, so 6 2 then L2 squared plus 6 A2 B2 bar. That's it. That's a division of 3 in with respect to 2. So after getting the division 1 we due to tangent 2 and division 3 due to 2, we will substitute it using this ratio proportion formula. So we simplify it by using this one, h1 over l1 minus t1 over 2 over l1 division of 3 over 2 over l2 minus h3 over l2. So plug division 1 this equation, so h1 over l1 minus 1 over 6 ei times m1 l1 squared plus 2 m2 l1 squared plus 6 a area 1 a bar 1 times l over 1 l1 over l1 equals 1 6 ei times 2 m2 l2 squared plus m3 l2 squared plus 6 a2 b2 times l times 1 over l2 minus h3 over l3. Wait, there you go. You see me? Yes. And then we simplify it by transferring this h3 over l2 to the other side. Then we multiply this l1 and l2, 1 over l1 and 1 over l2. So we get this. So so we cancel l2. This one will be l2. This one become l2. This one l1 l1. So we get this equation. We simplify. Now next we simplify it further by forgot. 2l2 multiply this to the other side, this one we combine, so we got this equation, h1 over l1 plus h3 over l2 equals 1 over 6 ei times m1 L1 plus 2N2 times L1 plus L2. From this one, we multiply this one, and then N3 L2s, same, plus this one, and then this. So H1 over L1 plus H3 over L2 equals M1 L1 over 6 EI1 plus 2M2 times L1 over 6 EI1 plus L2 over 6 EI2 plus N3 L2 over EI2 plus A1 A bar 1 over EI1 L1 plus A2 B2 over EI2 B2. So you're wondering if why but manong na I1 EI2? Okay, with different cross section and materials. So nay uban materials nga cement o steel, so dili siya, not all EI are the same, so EI1 EI2. So simplify it further. So this was multiplied by 1 over 6 EI ini i-multiply na siya. Dayon sa i-multiply din ang gawas sa 6 EI both sides. So muna siya ang formula. So to arrive at the final formula, i-state sa definition sa three-moment equation na equation na two adjacent span with or without vertical displacement at the support. So kaning three internal support, kung like isa or any internal or connection or support, ang vertical displacement kay mahimong 0. So kaning H1 o H2 mahimong siya 0. So atong final formula kay M1 L1 plus 2N2 times L1 plus L2 plus N3 L2 plus 6 A1 A bar 1 over L1 plus 6 A2 B bar 2 L2 equals 0. So muna siya equation atong gamiton for the following examples or problems na atong isolve. So factors for the three-moment equation. So the table below lists the value of 6a a bar over L and 6a b bar over L for different types of loading. So types of loading. So kung ang P, so wala siya ito nga. So P sa 6a a bar over L, so PA over L times L squared minus A squared. Then dito sa B is dito sa B ang PA, PB siya. So if nasa mid span ang concentrated load, ang A ug ang B kay ilisan lang og L over 2. So mayroon siyang 3PL squared over A. Both of them. So sa uniform load, so WL cube over 4. Both in A and B. And then sa increasing triangle load, null span kay 8WL cube over 60 on A. Tapos sa B kay 7WL cube over 60. Sa decreasing triangular load, 7, so opposite siya, 7WL cube over 60. Then sa pikas kay sa B, WL cube over 60. Then sa isosceles triangle, so equal sila, 5WL ang equal ang sa A side o sa B side, the 5WL cube over 32, then 5WL cube over 32 sa B. And then sa general uniform load, this one mas taas ni. So So W over 4L B squared times 2L squared minus B squared minus A squared times 2L squared minus A squared. So sa B, ang B kay sa B ang kaning B variable B kay ilisan lang D yang A kay C. So W over 4L times D squared times 2L squared minus D squared minus C squared times 2L squared minus C squared. So sa moment load at any point of the span, minus M over L times 3A squared minus L squared. Then sa B side, M over L times 3B squared minus L squared. So, if di nato ni sila ma-memorize na atay makahimutag general formula. So, kuhaon lang nato ning aning point load at any and then kuha siya and then magamit tag uniform load. Then we put a magkuha tag P and P ug ang height paon sa nato here, tas magamit tag infinitesimal element. So so para makuha ang P, ato ra siyang kuha ng area which is y times dx. So P is equals to y dx. So para makahimo ang equation, so kaning distance A may siyang distance x, tas ang distance B may siyang distance L minus x. So kaning kopyaron natin siya diretso ta mag-base sa formula. So kaning P, so y dx should be times ang a which is x over L times L squared minus x squared. So muna siya, and then take 0 to L, so 0 to L. Okay. Then similar lang sa B. So sa A side, sa B side is so y dx times ang B which is L minus x over L times L squared minus L minus x squared. So ang final niya, ito siya i-simplify. So y L minus x over L times L squared minus L minus x squared dx. Same here. Got. So yx L over L squared minus x squared dx. So kani siya nga equation, magamit ni siya sa tanan loading, type of loading. So for 3-moment equation, example number 1, determine moment over the support B of the beam shown in the figure. So we have a increasing triangular load and concentrated load and a distributed load. So first, itong gamito ng formula, so 3-moment equation. So M1 times L1 plus 2M2 times L1 plus L2 plus M3 times L2 plus 6 A1 L1 plus 6 A2B2 L2 equals 0. So let M1 equal MA, M2 MB, and M3 equals to MC. So si M1 kay hinge man siya, so upper and vertical and horizontal forces naman na siya yung reaction, so 0 na siya. Pati si roller, C0. So first, so side A is the AB, side AB. Atong unahan i-solve. So at AB, at AB, sakto. Meters. So we'll use the general equation solving the moment. Para mas masabtan ang process. Newton meter. So kuhaon na tong height una and ang x para sa general equation. So kung red, so dire itong height y, so and x. So to get the y, we use ratio proportion. So y is equals to 350x. Moving on sa formula. So 6a bar 1 over L equals, well, siyempre may L, so it doesn't matter na. 0L, so yx over L times L squared minus x squared dx. So i-plug lang. I-hope makita siya. So 0 to 4 yung limit. So y is 350x times x over L, which is 4 meters, times 4 squared minus x squared dx. So ato i-calculate. The answer is 11,946.67 Newton meter squared. If i-try nato siya solve sa using this formula, Ano sa table, ito i-check if same lang. So 6A1 A bar on L equals 8 L cube 60 equals to 8 times ang load niya, which is 1,400, times yung length cube 60, which is same lang, 45.67. So siya. And then sa segment BC, on side B, we have a concentrated load and a distributed load. Oh, forgot the moment. So may moment din dito. We have a roller, both sides, distributed load, 800 Newton meter. Ito pa ba? And a concentrated load of 900 Newton. One meter. Ang total niya ay 4 meter. So kunin natin is this side, the L minus X, which is 4 minus X. So X 4 minus X and X. So formula is ito for the side B, 6A 2B bar 2 over M is equal to limit to 4 y times L minus X over L times L squared minus L minus X squared dx. So first ang distributed load, which is 900 times L 4 minus X, which is 1. Ito ba? Yeah. Yeah. And then 4 squared minus 3 squared plus 2 4. So 800 distributed load, 800 times ang L 4 minus X over 4. Then times sa 4 squared minus 4 minus X squared dx. So if you calculate it, so 6A2B 2 bar over L is equal 10,325 Newton meter squared. Tapos, ato lang i-plug ulit dito sa formula. So, since MA, M1 is 0, and M3 is 0, this is cancel. So, ang matira ay 2M2L times L1 plus L2 plus 6A1 bar L1 plus 6A2 B2 bar over L2 equals 0. So 2M2 is equals to 2MB 2MB times 4 plus 4. So they have the same length, side A and side B. So plus this one 11,946.67 plus 10,325. So MB is equals to negative 1,391.98 Newton meter. So that's the final answer for example number 1. So for the 3-moment equation example number 2, determine the moment over the support P of the beam shown in the figure. Okay, so similar lang sa example 1. First, since it's a continuous beam, we'll use a 3-moment equation. So M1 L1 plus 2M2 times L1 plus L2 M3L2 plus 6A1 A bar 1 L1 plus 6 A2 B2 bar L2 equals 0. So let M1 equals to MA. So since it's a hinge support, wala siya moment, so 0. M2 is equal to MB and M3 is equal to 0. Also 0. Because it's a roller. So let's start in the first span, which is at AB. Okay. Since it's a concentrated moment, we will use the side A formula, this one. Negative M over L times 3A squared minus L squared. So 6 over A 1 times A1 times A bar 1 over L1 equals ML times 3A squared minus L squared. Okay. 1 L1 active. So moment, which is 300 pound-feet over L, which is 9 feet, times 3 A squared. So 3 3 feet. 3 squared minus 9 squared. Calculate. So 6 side AB is equals to 1,800 pound-feet squared. So at second span BC, we will use the left side, left side of the call that beam para dili trapezoidal, no, mga tong atong triangle. Okay, so we have a x, so x x roller at C. £100 feet. So kuha lang na tong L minus X dire para dili siya trapezoid. Ito mag-lisod 3 feet here, 6 feet. Tas gamiton din na tong general equation. So determine the height. Determine the x first. So the height y. So y is equals, just use ratio proportion. X tapos kini L minus X. Muna itong gamiton sa itong general equation. So y over x equals 100 over 6. So y is equal 116.667 times x minus 30. I mean x minus 3 pala. Kasi dito x minus 3 to. The proportion part. So we'll use the second span side B formula. 6A2 B bar 2 over L2 equals x1 x2 y times L minus x over L times L squared minus L minus x squared dx. 6a squared. So we plug in the values. So nag-start siya at 3, then 9 ang limit, and then y is 16.667 times x minus 3 times L minus x, which is 9 minus x over 9 times 9 squared minus 9 minus x squared dx. After, calculate using calculator. 2b2 over L2. So we have 4,680.094 pound feet cube. So ato siya i-plug. Cancel this. May 0 ni. M3 ug M1. Ayan. So 2m, oops, 2m, let's put mb na lang. Ano, L1 plus L2 plus 6 a bar 1 over L1 6 a2 b2 bar L2. Plug, substitute the numbers. 2 mb is 9 plus 9 as 1,800 plus 4,608